Hello everyone and welcome back to my channel Quality Talks. In the previous video, we explored the fundamental of measurement system analysis MSA. In today's session, we will dive into a practical case study where we will evaluate a real measurement system, perform essential calculations and interpret the results. By the end of this video, you will clearly understand how to assess repeatability, reproducibility and overall capability of measurement system. We will do the measurement system calculation with this case study. In this example, we are analyzing the rivet filling diameter which has a specification of 13 mm plus minus 0.5 mm. The measurement instrument used is a digital vernier caliper with a measuring range from 0 to 200 mm. We have three inspectors, inspector A, inspector B and inspector C, and 10 parts. Inspector A measures all 10 parts, inspector B measures the same 10 parts, inspector C measures the same 10 parts. This entire sequence is repeated 3 times. We have 3 inspectors A, B and C. The variation between these 3 inspectors will reflect appraisal variations. It is also known as reproducibility. We have 10 parts. Variation between these parts will reflect part variation. Each inspector will check each part 3 times. So this will reflect within system variations, that is equipment variation or repeatability. Before running an MSA, selecting the right parts is crucial. Since our goal is to compare measurement system variation against actual part variations, the part must present the full range of variation present in production. Therefore, we should pick parts that covers the lower range, the mid range and upper range of the tolerance band. In this case, we selected 3 parts from lower range 12.85 to 12.95, 3 parts from mid range 12.96 to 13.05 mm, 4 parts from higher range 13.06 to 13.15 mm. If we select parts with very limited variations, the part to part variation will appear slow and the MSA result will not accurately reflect the true capability of measurement system. Now let's understand how to record observations during an MSA study. To ensure accurate results, it is critical to eliminate inspector bias. For this purpose, inspectors must not be able to see the part serial numbers. Parts should be presented randomly, not in any fixed or sequential order to the operator. A separate coordinator or recorder should note down the measurement announced by each inspector and record them against the correct part serial number. This process must be followed for all the inspectors and the entire sequence should be repeated 3 times to complete the study. Now let's move into the calculation phase of the MSA study. First, we enter all the readings provided by the inspectors into the MSA worksheet. For each inspector, we calculate the average and range for every part. For inspector A, part 1, we have 3 readings 12.880, all 3. So the average will be 12.880 and range will be maximum minus minimum, that is 0. Similarly, for inspector A, part 2, the average will be average of all these 3 readings, that will be 13.007 and range will be maximum minus minimum, that is 0.010. In this way, we will find all the averages and ranges for inspectors and part combination. There would be 30 averages and 30 ranges. Further, we will calculate XA and RA. XA is the average of all these averages. So it is the average of inspector A. Then the RA is the average of all range for inspector A. So all these readings divided by 10 will come as RA. Similarly, we will find out XB, RB and XC and RC. Now we will calculate part averages. For part 1, we have average of inspector A, average of inspector B and average of inspector C. Average of all these three average will be the part average for part 1. Similarly, we will get part average for part 2, part 3, part 4 up to part 10. Now we will calculate X difference. X difference is the difference of max of XA, XB, XC minus minimum of XA, XB, XC. So we will find out max of XA, XB, XC. So maximum is XC, that is 13.0370 and minimum is XA, that is 13.0317. So X difference will be 0.0053. Now we will calculate R double bar. R double bar is the average of RA, RB, RC. So we have three reading RA, RB, RC. We will take average of it and that is 0.011. Now we will calculate RP. RP is the max part average minus minimum part average. So we have 10 parts average. Maximum is 13.254 and minimum is 12.884. So the difference of these will be 0.37, that is RP. We know X difference is the parameter related to the difference between the averages of different inspectors. So this parameter will go into the appraisal variations formula. R double bar is the parameter related to same operator, same instruments, different reading at different times. So that is within system variation, and this component will go into the equipment variation formula. RP represents the variation in the parts. So this will go into the part variation formula. Now we will calculate three key statistics: equipment variation repeatability, appraisal variation reproducibility and part variations actual part to part variation. Equipment variation repeatability. The formula is EV is equal to K1 R double bar, where K1 is a constant that depends on number of trials. In our study, each inspector measured each part 3 times. So K1 will be 0.5908. R double bar we have already calculated. So EV is equal to multiplication of K1 and R double bar. The result will come as 0.0065. Now we will calculate appraisal variations AB reproducibility. The formula is AB is equal to square root of X difference multiplied by K2 square minus EV square divided by NR, where K2 is a constant that depends on number of appraiser. We have 3 appraisers, so value of K2 will be 0.5236. N is number of parts, that is 10 here, and R is the repetitions, that is 3 here.
So by putting all the values, AV comes as 0.0025. Now we will calculate GRR, gauge repeatability and reproducibility. So GRR is equal to square root of EV square plus AV square. So by putting all the values, GRR came as 0.0070. Now we will calculate part variation. The formula is PV is equal to K3 into RP. RP we have already calculated. So K3 is a constant for the number of parts. So we have 10 parts. So value of K3 will be 0.3145. So by putting these values, PV came as 0.116.
Now we will calculate total variation. Total variation is equal to square root of GRR square plus PV square. By putting both the values, we get total variation as 0.117. Now we will calculate percentage EV, percentage AV, percentage GRR and percentage PV. To get the value of percentage EV, we will divide EV by TV and multiply it by 100. With this calculation, percentage EV came as 5.57. Similarly, we will calculate percentage AV, percentage GRR and percentage PV. Now we will calculate NDC, number of distinct categories. The formula is NDC is equal to 1.41 multiplied by PV divided by GRR. By putting the values, we get NDC as 23. Now we will see the criteria for MSA acceptance. Percentage GRR less than 10%, that means measurement system accepted. Percentage GRR 10 to 30%, measurement system can be accepted but based on application and cost. Percentage GRR more than 30%, measurement system is not accepted. In our case, percentage GRR came as 5.98%, which is less than 10%. So measurement system is accepted. With respect to NDC, the criteria is if NDC is more than 5, then measurement system is accepted. If NDC less than 5, then measurement system is not accepted. In our case, NDC is 23, which is higher than 5, so measurement system is accepted. So we are meeting both the criteria, percentage GRR as well as NDC. So our measurement system is accepted.
Thank you so much for watching this video. I hope step-by-step calculations and the real-life case study helped you understand the complete MSA process more clearly. If you found this session valuable, please like the video, subscribe to the channel Quality Talks and press the bell icon so you don't miss further videos on quality tools and industrial best practices. Your feedback and suggestions are extremely important to me. They help me improve and bring more meaningful content for you. So don't forget to share your thoughts in comment section below. Thank you once again for your time.